That's right. So Edgar just said I'm supposed to talk about science and arts and how they are connected or not connected or something. Thanks for informing me right now. Figure out what I have to say. So safest thing is when you have written a book is to start reading from the book. This book is twice written, and like all the Bombay writers, let me say, it's available here right now and you can buy it. I'm very bad at that. I did give some thought to what I was going to say today, but it all kind of changed after an event this morning which I'll come to soon. But let me start. I am a theoretical physicist, and it's usually not fully comprehended by the much wider community what theoretical physics is about and how does theoretical physics stand in relation to any other kind of physics and why do we underline that. And let me start by reading something from my very famous book. If you saw the poster, it says something about explorer of spacitudes, autopsychographer, where's Tanvi? Tanvi is probably and autopsychographer, explorer of spacitudes and crossword buff. So actually my talk today will touch upon all these three things. I'll start with the crossword bit, then go on to talk about spacitudes some time later and eventually also autopsychography. So this, people kept asking me when I decided to write a book whether I'm going to be writing science fiction, and I said it's a genre that doesn't interest me at all, and anyway the kind of science I do is a lot of fiction, so it's no point trying to invent a new kind of fiction. My character, there's this guy called Prahlad who is a 19-20-year-old and he's very keen on physics. He's not doing physics, he's working in a typesetting firm. In fact, just around the corner from here, where you would remember where Thacker's bookshop used to be. And that's where he's working, but he's very, very excited about physics and wants to do physics. But at the moment he's having breakfast in what used to be Madras Cafe. In fact, we can write a book about all those places that have disappeared in this area. And after he's finished his dosa, vada and coffee breakfast, he's now spending some time looking at a crossword. The Times of India from Bombay used to actually be a newspaper at one time, and it had a decent cryptic crossword, because they were reproducing the cryptic crossword from Daily Mail, and it used to be quite interesting. So Prahlad's passion for crosswords and his passion for theoretical physics were not unrelated. He remembered a teacher in college who disapproved of Prahlad spending time on solving crosswords. "You'll never be able to pursue physics if you waste your time on such idle pastimes," he remembered his teacher saying. "But sir," he had said, "crossword clues are so like the experimental data that a physicist works with. There are some set procedures he follows, but he also needs considerable ingenuity to crack a clue. In physics, as in a crossword, the solution does not make sense if it does not fit in with existing solutions to other clues. How can you even compare physics to something as trivial as a crossword?" said his teacher, irritated. Trivial is in fact a physics word. Okay. So, how can you ever compare physics to something as trivial as a crossword, said his teacher, irritated. "Physics may be more complicated," said Prahlad, and there is one profound difference. Which is, well, the issue of the compiler. Physics is agnostic. It tells you that just because there is a crossword, it does not mean that there is a compiler who put it together. Don't you agree? He had seen a faint light of understanding dawn in his teacher's eyes. Very often, Prahlad had continued, a physicist gets so carried away cracking a few difficult clues that he becomes atheistic and claims that there is no compiler. So this is the kind of brief a theoretical physicist is. I mean, he's basically like a crossword buff. There are experimental data, things to be put together from experiments, and he believes that. And I'm using he all the time because all theoretical physicists are male. We know that for fact. Okay. And I'm teaching a class in TIFR right now, and there is one girl in a class of 25. And she doesn't even want to become a theoretical physicist. Anyway, so I was saying that theoretical physicists have this very, very grand picture of themselves. And because almost, we have this whole system of stars in theoretical physics, and almost every scientist, I bet you can name off is a theoretical physicist, right? So, let me ask someone. Someone wants to venture the name of a scientist? Randomly, don't think. Einstein. It's all theoretical physics. If you said Newton, it would have been theoretical physics again. Okay, so they somehow have this kind of myth building in theory physics, and they try to make these glamour boys of theoretical physics. The point I was trying to come to is that within theory physics circles, they have their own idols. Okay, so for us, outside theory physics, Einstein may be the real theoretical physicist. But if you ask a theoretical physicist from inside, then they would actually name someone else. And this is a person called Paul Adrien Maurice Dirac. So Dirac was actually a theoretical physicist of theoretical physicists, and he was very, very famous in that circle. And Dirac is known for his very pithy and pithy comments about anything which didn't have to do with physics, in fact. And there was an occasion when I think he was having a chat with Robert Oppenheimer, and Oppenheimer was interested in dabbling in poetry, and Dirac apparently told him, how is it possible for you to do physics and poetry together? It's just not possible. And Oppenheimer said, no, I think I share a passion for both, and I don't see why I shouldn't do it. And Dirac replied, physics makes complicated things simple, whereas poetry makes simple things complicated. So this was Dirac's understanding, and I don't know whether you all agree with it, because I'm sure if you have ever studied a book of physics, or even a book of popular physics, you probably thought it was very, very complicated. It doesn't look really simple. So what would he have meant when he said it was simple? It could be said that he meant that it is logically simple. So, things which seem complicated because they use a lot of jargon may, at a logical level, be simple. And that is probably the sense he meant it. But he was completely oblivious to the fact that, it's eventually an issue of language. I mean, that if you are comfortable with a certain language, then communication in that language is possible, understanding in that language is possible. If you have grown up reading poetry, understanding poetry, listening to poetry, then poetry is what will come naturally to you, not physics. So this huge divide kind of marks physics, and actually when young people get into doing physics, they are often told the story by Dirac, and in fact they then look down upon anyone who would pick up a book and start reading either poetry or literature or whatever. So this division between the world of arts and world of science is very, very firmly established by comments by people like Sridhar, for example. But I also wanted to add that to a lay person, physics actually seems very, very abstruse, simply because it uses, for one, a mathematical language. That is one thing. But even if you try to avoid the mathematics and talk about the physics in purely linguistic terms, the concepts always seem abstruse. And this actually makes it very interesting in a way, because what people associate with very sort of cutting edge concepts in theoretical physics, let me just say a few, like let's say black holes or wormholes or extra dimensions or things like that, or parallel universes. These are the kind of stuff that you'll see being mentioned in popular literature on science, and people usually associate with this a very, very strange understanding. Okay, so they think physics is actually somehow connected with a very weird world. This world is almost an occult world, and it's everything that science is not supposed to be. So it's actually science trying to divorce itself from the mystical and the occult and move towards this very, very empirical understanding of the universe. But funnily enough, the most speculative theories of science, which are in some sense very difficult to grasp, are always understood by the general audience in terms of concepts like the occult. And very often I've had experiences where I'm talking to an audience and someone says, yes, I belong to such and such religious group, and in our own religion we have some concept which is exactly what you are saying. So I can't even see the similarity, but that person is convinced about the similarity because they came in the first place expecting to see some connection. And that's actually a strange twist, because physics or science in general tries to place itself firmly on empirical foundations. But then there is always a strain, because you can use experiments to explore so far, but if what you want to do in your building of theoretical models is to go much beyond what experiments have proved. So that region remains always very speculative, and it is in this speculative region where there is a lot of attraction, there is a lot of popular attraction, but at the same time it is open to this kind of an understanding. And that's what brings me to the incident of this morning, which was I went on to Facebook this morning and saw a post from a friend. I don't know how many of you saw this, but there was some incident in CERN. CERN is this huge particle physics experimental center in Geneva, and they have this massive accelerator which is 27 kilometers long, and they recently discovered the famous Higgs boson, which everyone knows about. But there was this incident 2 nights ago in CERN where a group of possibly summer students who were visiting there had a little more than they should have been drinking probably, and they decided, so in fact in CERN there is a huge statue of Nataraja which was gifted by the Department of Atomic Energy India to CERN as a mark of the collaboration between the two countries. And these guys went in black hood and stood in front of the statue, and they filmed this whole thing. They went and did a kind of ritual in front of the statue, and at the end of this ritual they drag a woman and pretend to kill her. And the person who is shooting this then is seen to run away. I mean, you can see the camera just moving away and he's completely shocked. This video has gone viral. If you go onto YouTube, you'll see it, and it also uses rather offensive language, so be careful. But what I was interested in is looking at the comments, so I spent all morning today seeing what kind of comments you have at the end of this. And of course there were many comments, some saying, well, one should just ignore it, it's just a bunch of very drunk people doing something stupid. CERN has of course officially distanced itself from this whole thing and said they don't appreciate this kind of humor, even if it is humor. And but there are lots of people in that list, or in that thread, sorry, who are saying things like, but this is what science, this is the kind of science that CERN is doing. We give them money and they are actually trying to explore parallel universes and extra dimensions. And they actually think by reading books like Angels and Demons and all that, that the way to explore all these, so-called occult mystical concepts is to do these kind of shamanic rituals possibly. And so they actually see a connection between this ritual. They actually believe that someone was actually sacrificed there 2 nights ago. And they believe that sun is doing this. And they say, of course, it's a waste of our money. But at the same time, they believe that this is what sun is into. And it's actually an example of what one would call in psychology counter-projection, which Jung talks about. Basically, you project all the negative values conscious onto someone who's your antithesis, but that funnily comes back to you. And this is exactly what science has been doing. Science has been trying to distance itself from the occult and from the mystical without completely realizing. It would be interesting to put science itself as a system on a couch and investigate. And if you delve deep into the subconscious, or rather the unconscious, you'll realize that the origins involved alchemy, involved magic, involved a lot of things which science has in its attempt to become an empirical knowledge system, distanced and divorce itself from. But that distancing has happened in a rather abrupt way. We were talking about this in some sense, so epistemic suicide is probably what I would call this. But basically it has taken elements which it has come out of and tried to distance itself from those elements in a very, very drastic way. And the transition has not been a gradual transition, which has actually caused this kind of thing, because I feel this is some kind of counter-projection coming back to science itself. This accusation of being something mystical and occult and actually far removed from people's lives. So it's actually interesting travesty. I'll go back to reading a bit from the novel again. This talks now again about this collision between these two worlds and the way science posits itself and posits itself against a world which is pre-modern, which is dark, which is chaotic, against the deterministic, very well laid out world that science has to offer. Again, this is Prahlad, and Prahlad is got into carom and he's watching some 3 friends play carom. It was just past sunset when Prahlad stood at the door of the carom room, watching Mohan and 3 others play. The room was right opposite Muktabai's home, and as was the practice every Tuesday evening, women had gathered inside to take part in a weekly ritual dedicated to goddess Bhavani of Tuljapur. The room was so packed that the door had to be left open so that some of them could sit near the doorstep. It was a scene that immediately attracted Prahlad's attention. A small picture of Bhavani rested against one wall, and the women sat around this picture huddled together, dressed in reds or greens or flaming oranges. They had all let their hair loose and had red kumkum smeared on their foreheads. They were chanting and singing the praise of the goddess, but not very loudly, and were swaying gently to the music. "Look at him," said Mohan, raising his head after playing a shot. "He's more interested in looking at those women there." The boys laughed and Prahlad embarrassedly looked away and tried to focus his attention on the game. But he couldn't help turning back to look into Muktabai's room a little later. The goddess had made her appearance now. She was somewhere in the room. Of course she was not visible, but she was making her presence felt through the bodies of the women there. Here she struck one old woman, there a young 16-year-old. She was moving through the room possessing these women at will. Not unlike the striker hitting the coins on the carom board, one after another. The goddess moved from one corporeal location to another. But while the mechanics of the carom striker and coins was clearly spelled out, the logic of the goddess's ways was inscrutable. Without even being conscious of it, Prahlad was occupying a very interesting location, a threshold that offered him a simultaneous view of two events. It was a location in between two opposing worlds. One, a deterministic, enlightened modern world, while the other, a pre-modern, dark, chaotic world of the goddess. So, I'm going to now switch gears and come to the next bit about specifics, which is what I promised I would talk about. But it's not so completely disconnected from what I was saying now. And this, in fact, is a very, very good example of an idea which is very current in physics. It's very speculative. We have absolutely no empirical evidence for it. It is something I have spent last 18 years working on, and I have no hope that it will be seen, in experiments in my lifetime. But because it's speculative, it's open to all those kind of interpretations that I talked about earlier. But it's also a great example to talk about because it has very interesting origins, and when we talk about this subject, we somehow don't go back to its historical origins. So I want to spend a little time doing exactly that, going back to the history of this fascinating subject. And this subject that I'm talking about is called extra dimensions. And the question is very, very simple. The question is, do we know whether this world is a three-dimensional world as we see it, or are there more dimensions of space? I mean, we see the world that it has length, breadth, and height, but beyond these three dimensions, are there more dimensions to this world? Okay. So I'll tell you later why this is so interesting a question in physics. But one can start by saying, oh, but this is ridiculous. We know that there is only length, there are only three dimensions, length, breadth, and height. So why do we even ask this question in the first place? And science is supposed to be empirical, so what is this whole thing about? The issue is, do we really see dimensions which are not so easily accessible to our observations? So the idea is, imagine you have, so just to make it clear, I mean, we know what dimension means, but I'll just reiterate. A line, for example, is a one-dimensional object, a plane is a two-dimensional object, and three-dimensional space is something that we live in, and so on. Okay. So imagine you take a sheet of paper, it's a plane, so it's two dimensions, it's got length and breadth. Now if you were to take this paper and curl it up and make it into a straw, and make that straw very, 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 very thin. In mathematics, this process is called compactification. So, and if you look at this thin straw from a distance, then you would see it as a line. So effectively, you see a one-dimensional object, where to begin with you had a two-dimensional object. But then you say, oh, but wait a minute, if I go really close and observe it, I'll see that there is a curled up dimension, that there is a circle there. I can see that circle on the straw. And that's right, so you have to really observe very carefully. In science, usually in particle physics, when you say you have to observe very carefully, it means you have to observe it at very high magnification, which basically means you have to look at it at very high energies. So that's why we build all these huge accelerators where we can do experiments at very high energies to look at these very, very tiny objects. So the point is that what looks apparently like a one-dimensional one-dimensional line is actually a two-dimensional object with one dimension curled up. The big question is, are we living in a world like that? I mean, are we living in a world where there are more dimensions than we know in a very obvious way, in an apparent way. And we have great reasons to believe, again from theoretical mathematical ideas, that in fact the world is 9-dimensional. Okay, there's the 10th dimension which is time, but let's not go there. But there are 9 space dimensions. So at each point now, each point in space, there is a 6-dimensional sphere which is curled up into a very, very tiny size. It's so tiny that we don't see it normally. It's probably so tiny that we'll never see it and therefore never know whether this theory is true. But if we are lucky, and that's what my other book is all about, then we may be actually able to see it in experiments like the one in Geneva, and we may be able to know that there are more dimensions than 3. Why 10 dimensions? The reason why 10 dimensions is interesting, or 9 plus 1, by 10 I mean 1 dimension of time and 9 dimensions of space. And the reason why 10 dimensions is interesting is because there exists a theory which you have all heard of called string theory. And string theory is a theory which allows you to combine quantum mechanics with gravity in a nice way. It tells you about everything possible in this world. It makes you a cup of coffee and everything. So it's perfect. Except that this theory makes sense only in 9 plus 1 dimensions. Okay, it doesn't make, it's completely mathematically wrong if you had it in 4 dimensions. So what you basically do is it's like a process of inference, and you work out everything. All the details seem to fall very nicely in place, but at the end of the day, not from just one mathematical consideration, but from several angles, you come to the conclusion that there ought to be 9 space dimensions. So then the question is, if these 9 space dimensions exist, are they curled up? And if they are curled up, can we actually do experiments to find them? So that is why this whole subject becomes interesting. But where did all this really originate? I mean, when was the first time someone thought of an extra dimension? Of course, these are always tricky areas to get into, because when you say first time, then someone will say 3,000 years ago, by the Ganges, there was a person sitting in a hut and he had figured it out. Okay, so power to him, of course. But from what we know from extant history, there was this very interesting person called Henry Moore. Henry Moore, not to be confused with the artist 20th century, but Henry Moore, who was a contemporary of Newton. In fact, he worked with Newton in King's College in Cambridge, and he was a senior colleague of Newton. And Henry Moore was actually, he was a philosopher, let's say. He was a Neoplatonist, and he was actually very taken up with Newton's ideas. Newton himself was very influenced by Henry Moore in his conception of what space is. So the idea of Newtonian space derives a lot from Henry Moore's ideas. But Henry Moore thought that if Newton's mechanics gives you an understanding of all motion and therefore all dynamics in the 3-dimensional world, then so basically the physical world is explained by Newton's laws, and Newton's laws work in 3-dimensional space. Then he said that there must be an extra dimension, a 4th dimension of space, in which in this 4th dimension, consciousness and the psyche and things operate. So he kind of posited a spiritual dimension, let's say. But this spiritual dimension was not just a word. He actually formulated a 4-dimensional theory. So he made a mathematical theory of 4-dimensional world. So this was the first attempt at doing that. And his thing was really an academic exercise, saying, okay, we have to consider that the world is just not physical, but there is something beyond the physical. And in order to accommodate this component of psyche and consciousness, he is positing a 4th dimension. Okay. Unfortunately, I think the idea was too premature. I mean, you have to imagine this was just around the time Newton was writing his theory. So people didn't respond to his ideas very warmly, either in the physics or in the math circles. Okay. The philosophers also did a cold turkey on him, so he was not taken up by the philosophers either. But then he developed a fringe following. And that fringe following continued for several centuries, okay, almost 250 years. There were a whole lot of crazy people. I mean, I would call them crazy hindsight. But people who kind of believed in Henry Moore's theory in ways that Henry Moore had never intended it to be. Of these was my autopsychographer friend, Fernando Pessoa. I guess some of you have heard of Pessoa. Pessoa was a 20th century poet, and he lived in Lisbon all his life. He traveled very little. He was not known outside Lisbon as a poet for a long time. And it was only in the 90s that his work was revived and translated in French. Then he became a hero in France, then in the Anglo-Saxon world, and now he is celebrated as one of the five priests of modernism. And Pessoa is remarkable because he's inspired, several books. Jose Saramago wrote a book on the year of the death of Ricardo Reis, and this was a book he had actually dedicated to Pessoa. Except that Pessoa was not one person. Pessoa was a colony, as we say in Bombay. Okay. There were many people living inside him. And there were at least 4 poets we know who resided in this corporeal location called Fernando Pessoa. And they had different names, but it was not just different names, they were not pseudonyms. He preferred to call them heteronyms. And these were people who had different lives, life experiences were completely different. He imagined totally different histories for them. They had different scholarships. So one was an expert in Greek poetry, whereas the other one was a modernist. So I can actually read Pessoa and say, Alvaro de Campos is what I really like. Okay, Alvaro de Campos is one of the names of Pessoa. Ricardo Reis, the character in Saramago's book, is another name of Pessoa. So he had these different identities, and these different identities were so beautifully crafted that they wrote different poetry, and the poetry is strikingly different. So in short, this guy was a complete madman. He was multiply schizophrenic, but he's amazing. He's one of my favorite poets. Pessoa had also another interesting story about him, and that is that he used to often meet and talk to Henry Moore. And you might wonder that I'm getting my dates mixed up because I just told you Pessoa lived in the early part of the 20th century, and Henry Moore was a contemporary of Newton, lived in the 17th century. The reason he met and talked to Henry Moore was Pessoa was into this, what is it called? Not planchet. You hold a pen and automatic writing. Yeah, they call it also spirit writing or something like that. I forget now. So basically, he would get possessed by spirits, and then he would start writing. And much of his good poetry was written like that, probably. But he would also have conversations in this with people. So there would be Pessoa talking to someone, and very often the visitations were from Henry Moore. And why Henry Moore? Because Henry Moore had invented the 4th dimension, remember? So Henry Moore was, all completely wacko, crazy people like Pessoa. Henry Moore was the god. So Henry Moore would come, he had long conversations with Pessoa about his love life, non-existent love life, right? And all sorts of things. And Pessoa has very faithfully recorded all this. So I was very happy when I discovered this aspect of Pessoa because I was working in extra dimensions, and it keeps coming back to me in very many different routes. So There was this astronomer in, sorry, this is like a story, so please free to interrupt me and ask anything you want in between. There's an astronomer in Leipzig about 100 years after Henry Moore called Zollner. I forget, Frederick Zollner. So Zollner was actually also taken up by Henry Moore's ideas, and he was convinced that there's a fourth dimension. But Zollner was an astronomer. He used to do things with his hands, and he did observational astronomy. That part of his science, was quote unquote respectable. But then in his by evening, he got into another kind of science, which was trying to make some kind of experimental tests of Henry Moore's ideas. So he had the idea that, if something kind of appears suddenly out of nowhere, or if I have this book and it disappears, because this is a book written in my pen, so it will actually disappear quite like that without leaving a trace. But if something appears or disappears just like that, it could possibly be understood in terms of having disappeared into a fourth dimension. Okay, so his conception of dimension was quite different, but he thought he could do, when people claim that they saw things or they see things appear or disappear, or people claim that they saw spirits or there were astral appearances, he tried to see whether he could see a pattern in that and pin it all down to the existence of a fourth dimension. He also sat with a lot of people who claimed they had experience of paranormal or they had extrasensory perception, and he did very, very detailed tabulations of their experiences and tried to see some patterns in that again. So in fact, these were the first kind of experiments on extra dimensions. And this is the kind of following it had, and in fact went on to Madame Blavatsky. It inspired some people from the Theosophical Society. So, it really reached a lot of places. It didn't touch science at all for a long time. Except that in around 1911, 1912, Einstein and some others started working on what is called the general theory of relativity. This was trying to understand gravitation, and Einstein was trying to understand what gravitation means, and this was all after his special theory of relativity, which had to do with the fact that nothing can travel faster than the speed of light. So the question really was, if nothing can travel faster than the speed of light, let's say the sun disappears now, and we know that the light from the sun takes about 9 minutes to reach us. So we will see that happening only 9 minutes later. But the way Newton's gravity was set up, gravitational force would be instantaneously conveyed to us. There was no time lag at all. So Einstein tried to remedy this defect. He said that gravitational interaction also cannot communicate to us faster than the speed of light. And then he started attacking the theory of gravitation from this vantage point, and eventually set up a theory called the general theory of relativity, which, to put it in a nutshell, tries to understand this gravitational interaction. For example, the interaction between the Earth and the Sun, or the Earth and the Moon, or any two massive bodies which have a force of attraction between them. Einstein said this is not simply a force that you have to talk about between these two bodies. It's in fact a property of space-time. That space-time itself is curved, and the curvature of space-time, so the geometry of space-time is what gives rise to gravitation. So this is a kind of really abstract idea. I probably need a completely different lecture. I probably need 1 hour to even explain some of these things. But the basic point is that gravitation is a property of space-time, and the geometry of space-time allows you to understand an interaction like gravitation. When this idea became popular and successful, a linguist actually from, I forget now, I think he was in Hamburg, a linguist called Kaluza. He got excited about this idea. He said, in those days, of course, they knew only two fundamental interactions. The two fundamental interactions were gravitation and electromagnetism. So Kaluza said, well, if gravity can come out of the geometry of space-time, then is it possible to also understand electromagnetism in this way? And he said, yes, of course we can do that if instead of 3 dimensions of space, you ask that there should be one more dimension of space. So you have 4 dimensions of space and 1 dimension of time, so 5-dimensional space-time. The curvature of this 5-dimensional space-time, in a mathematical sense, gives you not just gravity but also electromagnetism. And this is then eventually took off, and these theories became called Kaluza-Klein theories, because Klein was a mathematician who gave this idea about compactification, the one I told you about in the beginning, of rolling up papers into straws. And these Kaluza-Klein theories were popular for a while, except that people found that our idea of fundamental interaction doesn't stop there with gravitation and electromagnetism. There are other new interactions that people found, nuclear forces, strong and weak nuclear forces. And much of the attention for next 50 years went towards understanding these nuclear forces. And eventually, by the 70s, when people had an understanding of all these 4 fundamental interactions, people turned back to these Kaluza-Klein ideas. And it came back, as I said, through string theory, where it was not put in by hand, but it became a kind of necessity, a mathematical necessity, that if you want your theory to have all these properties, then you're necessarily forced to have a space-time which has 10 dimensions. That is, you have 9 dimensions of space and 1 dimension of time. So this fascinating, bits of physics which have developed over almost 100 years, and which now are very much within the possible reach of experiments, actually had its origins in the very murky ideas that came from Henry Moore and was transmitted beyond. So this is something I wanted to talk about. How much time do I have?
6:15.
It's 6:15. Right. So now I'm going to again move a little from this theme of extra dimensions and things, which basically through which I wanted to give you a flavor of the kind of work I do in physics. And I want to now ask this question, whether it is actually possible to touch upon issues of science within literature without necessarily pretending to talk directly about science. And this is what I'll do over the next 15 minutes or so. So what I'm trying to say is that it's possible in literature to write a story which a reader can read as a story she wanted, but if the reader were aware that this connects up with some other concept, then it will be doubly meaningful for her. So that's the idea.
Stephen Hawking's did science and literature.
He did?
Stephen Hawking. Jules Verne, science and like 20,000 Leagues Under the Sea, science and literature.
Okay, I don't know about that. Okay, so this is one of the characters in my story, who's called Omkareshwara. a good old-fashioned Tamil Brahmin name. And Omkareshwar is studying, he's actually a science student in Presidency College in Madras. And he has a teacher who starts a science club and then asks Omkareshwaran to talk in that one of the meetings of the science club. And, so Omkareshwaran has, in much later period, has there's a dilemma in his life because his father, who's dabbling in all sorts of things and like astrology, his father predicts that he's going to die on a particular day. And so the background to that, the story is that, and Omkareshwar is very troubled by this prediction, and then his mind goes back to this talk that he had given in his college several years ago. So I'll just read the bit now. So sorry, this is slightly long, this piece. But, Professor John Holt, who was their physics teacher and the founder of the science club, had encouraged Omkareshwaran to present a talk on science and astrology. In the course of his research for the talk, Omkareshwaran chanced upon a book on the Renaissance mathematician Jérôme Cardin. Cardin was an Italian mathematician who was famous for his work on the solutions of cubic and quartic equations. Other than being a mathematician, Cardin was a physician of repute, a professional gambler, chess player and astrologer. Omkareshwaran was amazed by the story he read. So many vicissitudes were clearly more than one life could bear. There were stories about Cardin's illegitimate birth, his changing fortunes driving him to gambling over and over again. One son was a murderer, another gambler always on the wrong side of the law. A daughter who was a prostitute and died of syphilis. His trouble with the authorities because of his outspoken nature. His fame as the greatest physician of Europe for effecting several miraculous cures. And the controversy with the church for casting the horoscope of Christ. He was quite a character. While Omkareshwaran could only admire the mathematical genius of Cardin, he loathed Cardin, the cheat, the conman, the card player. In this image of Cardin, he could see his father, and this made him loathe Cardin even more. From his reading of Cardin's life, he suspected that Cardin must have also been a womanizer like his father. The book didn't say so explicitly, but which Renaissance intellectual was not a womanizer? But what shocked him most about Cardin, to this aspect of Cardin he devoted most of his science club talk, was what he interpreted as Cardin's perverse nature. This had to do with the legend of Cardin predicting the date of his own death. Cardin indeed died on the predicted date, and the legend was that he killed himself. Within the worldview Omkareshwaran had grown to accept, this was the only way Cardin's prediction could have come true, through suicide. If he had died a natural death on the day predicted, then Omkareshwaran would have thought it a coincidence. In either case for Omkareshwaran, it was a perversion. Perversion of the individual who used suicide to prove the system of astrology, or it was the perversion of nature which uses something called coincidence, something that defies rational explanation. Omkareshwaran's friend Sundaram was a student of literature in Presidency College. Okay. So he was a gifted writer and was already making a name for himself by publishing short stories in journals and newspapers. Sundaram could only laugh at the way his friend was agonizing over Cardin. Sundaram could only laugh at the way his friend was agonizing over Cardin. He argued with him, trying to get Omkareshwaran out of his scientific straitjacket. If Cardin died on the date he predicted Sundaram fell, then his prediction should be taken to have been verified, even if Cardin had taken his own life. For if it were not ordained that he would die that day, then such circumstances would have arisen as to prevent the act of suicide. Omkareshwaran wilted under the force of his friend's irrationality, but he had no good answer. Sundaram returned the next day with an obvious air of elation about him. He had spent the night writing a short story based on Cardin's life, but written it in the manner of a tale out of Hindu mythology. The more Sundaram had thought about the story of Cardin's death, the more convinced he had become of revisiting it with his imagination. The gist of the story was, Sage Cardana was a renowned astrologer who was known far and wide for the unwavering accuracy of his predictions. For someone so renowned, pride is usually his nemesis. Sundaram was going along with the canonical theme in classical Hindu mythology which revolved around the humbling of pride, Garva Bhanga. At some point, Kardana aspired to immortality and undertook severe penances and austerities in order to propitiate Lord Shiva. The power of penance in mythology is such that the god invoked has no power to ignore it or not be bound by it. Shiva had no choice but to appear before Kardana and grant him whatever he wished. Kardana was waiting for just... Again, the mythological ploy when confronted with such a request is to grant it conditionally. Shiva argued with Kardana that life is uncertain and immortality is a condition that is beyond uncertainty and therefore not possible within the normal conditions of life. Is there any phenomenon you know of which gives you grounds for certainty? Shiva asked his devotee. The proud Kardana immediately cited his predictive ability as such an example of certainty. Very well then, said Shiva smiling, you will not die as long as your predictions are verified to be true. If however your prediction fails even once, then you will die at the very end of the day. Your prediction is found to have failed. At this point, Sundaram departed from the traditional story plot and provided the unexpected twist. Kardana, a Tamil Brahmin of the kind Sundaram himself was, cunningly realized that it was logic and not astrology that would now grant him immortality. He selected a date at random and predicted that as the date of his death. If he were to actually die that day, his prediction would be true and therefore by virtue of his boon he would not die. On the other hand, if prediction were false and he would not die on that day, then he would die at the end of that day, making his prediction true again. The story ended with Lord Shiva quickly granting the wicked sage immortality unconditionally and making a silent promise to himself that he would never get into these deals with Tamil Brahmins again. So, this is a whole plot and it's actually amusing when it's written in this way. But the way I set it up in this story was, all this is happening in Madras around 1925. And around 1925, Bertrand Russell, who had actually authored a massive tome in the Foundations of Mathematics called the Principia Mathematica, in 1925, so Bertrand Russell's program, the Russell-Whitehead program was to see if you can reduce all of mathematics to principles of logic and therefore provide a strong foundation for all bases of mathematics. So in fact, one of the great proofs that exists in Principia Mathematica is a proof for 1 plus 1 equal to 2. So it's 1 is some concept, 2 and 2 is another concept, and addition is a third concept, and he can prove that 1 plus 1 equal to 2. Basically trying to say that arithmetic can be reduced to logic. But Bertrand Russell around 1925 discovered a paradox right at the heart of mathematics, which is called Russell's paradox, and it has taken a long time to address that. There are some kind of tentative solutions to it in mathematics now, but it's one of the foundational paradoxes in mathematics. Russell's paradox I can tell you in terms of set theory. It's a problem of set theory, but in fact the Russell's paradox is exactly the paradox that I bring out in the story of Kardana. But it's another simple way to understand Russell's paradox is to think of, since we are sitting in a bookshop, is to think of a library and think of library catalogs. So every library maintains a catalog, okay? But some libraries may be also entering the catalog itself as an entry in the catalog, and some libraries may not do that. So there are two kinds of libraries: libraries whose catalogs refer to themselves and libraries with catalogs which don't refer to themselves. Now think of making this library yellow page, a collection of all catalogs of all kinds. And imagine that you are making a collection, a big catalog, a super catalog. And this super catalog had entries which were catalogs of all libraries which did not refer to themselves. Okay, so every library which had a catalog which did not refer to itself, you include it in the super catalog. Okay. Now you ask yourself, does the super catalog contain itself or does it not contain itself? Because the super catalog contains itself, by definition it should not contain itself. If it does not contain itself, then by definition it should contain itself. So this is Russell's paradox. And it's, instead of catalogs I could have used the word sets, and it would have been exactly the way he formulated. So I actually took that same thing and redid it in the form of a story. And I think basically you get the same idea, and it's but it's more appealing in the form of literature than trying to put it in terms of boring set theory. So these kind of conversations between science and art is what I've attempted when I've been doing this book. Conversely, when I was writing my physics book, a lot of stories about Henry Moore and Pessoa naturally crept into that. And so I think I want to keep those kind of links alive, and because I think there's a synergy between these ideas. Forgetting some of these and erasing some of these connections is what really does harm to knowledge systems on both sides. Thanks.
Any questions you want to ask?
You refer to Einstein.
Yes.
You refer to Einstein theory of relativity. This is E equal to mc square. That would,
So, yeah.
that
So E
famous
equals
formula
is a
of
kind of popular.
yeah.
Yeah, that's a kind of popular formula which summarizes an earlier theory of Einstein, which is called the special theory of relativity. And what I was referring to was the general theory of relativity, which is more about gravitation.
Another question, you spoke about gravitation and relativity. If gravitation was, if I'm not mistaken, was Isaac Newton, who, as the story goes, that, and
Yeah.
then because I find it confusing when
Exactly.
you speak
Okay,
about.
sir, good, thanks. That will help me clarify some of it. So it was, see, many of these ideas have existed for a long time, even before Newton. So for example, the idea that the earth is not a flat surface, but that the earth is a huge sphere, is something that has existed for a very, very long time.
Galileo?
No,
Copernicus.
it has existed from 300 BC, from 200 BC, from the time of Eratosthenes, for example. At least from the time of Eratosthenes. Ignoring all those people who were sitting in huts along the Ganges. Eratosthenes actually not only understood that the earth is a sphere, he could actually sit in his own art and figure out that you could just use some observations people have made and calculate the circumference of the earth. The circumference that he calculated is very, very close to what is being now estimated. But then the problem with a spherical earth is people always ask what happens to people on the South Pole, what happens to the oceans on the South Pole, why don't they all fall off? Okay? Because we fall down. With Newton, basically the conceptual change that he made was that Newton said we don't fall down, the apple doesn't fall down, but the apple falls towards the earth. So no matter where you are on the earth, the apple falls towards the earth, it doesn't fall down. Okay, the absolute notion of a down goes away with Newton. Down is only defined in terms of where the gravitational force is pointing. So Newton's point was that if you have any two objects which have mass, any two bits of matter, then these two bits of matter have a force of attraction between them. It's always a force of attraction, it's never repulsion. And this happens for any two bits of matter. So for example, you and I would actually be getting pulled towards each other right now. Except that we are in the gravitational field of the earth, which is much, much stronger, so we don't sense the pull that we exert on each other. The tides that are caused on ocean surfaces or lake surfaces are also caused by the gravitational pull of the moon, for example. But while all this is true and much of this stays even after Einstein, Einstein made another shift. He said that, I am not exerting a force on you. What happens is when you are at your point in space-time and I am here at my point in space-time, our mass tends to curve the space-time around us. So he gave a different interpretation of the same phenomenon, but he could do it without invoking this metaphysical idea of a force. So there is a space-time curvature around me, a space-time curvature around you. Or to be more specific, let's say you have a really massive body like the sun, and then the earth is moving around it because of the fact that the sun actually curves the space-time around it to a huge amount. Extreme examples of such things are black holes, for example, which tend to curve the space-time around it so much. It's a very, very dense object that nothing can escape from the black hole. So such objects have been predicted by Einstein's theory and in fact even confirmed by experiments. They are not bits of fiction as people think, but they have actually been observed. You see both galaxies disappear into nothing. That is, they are going into a black hole. Okay. So this is actually the conceptual shift. I mean, it's from, so in fact what they had to do, Newton had already calculated orbits of the planets around the sun. What Einstein did was, in his theory, they could calculate the shift in the perihelion of Mercury. In the orbit of Mercury, they could calculate a small shift. It was very, very difficult to measure this shift astronomically, but they did that, and that was a confirmation of Einstein's theory. So the bulk of it is explained by Newton, small correction is explained by Einstein, if you look at it that way. But conceptually, it's a huge shift. So that's why Einstein's theory is what it is.
Another point when we talk about dimensional and three-dimensional, fourth-dimensional, fifth-dimensional, one is the scientific part and the second is an artistic expression of life or many dimensions of philosophy. Could you please highlight more in a more detailed of 3, 4, 5, 6, 7 dimensions of life?
No, I mean, sir, we could use the word dimensions purely as a, without any mathematical meaning attached to it. I was actually emphasizing how
dimensions of space.
Yeah, so when I say that, it has a mathematical meaning, dimension in a mathematical sense. So
just to build on to that question, I want to ask whether you would, because you started with the idea of a compiler and physics going with the idea that there is no compiler, so being agnostic. Would you call yourself the compiler of or even a part compiler of extra-dimensional theory which you've been working on? And I have another question. When you do your research, you spoke about the determinism and the very 2+2 world of physics and this world of imagination, a murky world of imagination. A very silly question. Just if you had to put it down into how this informs each other in terms of percentage. Would you say it's like 30% imagination and 70%?
yeah, it is a silly question.
But just to imagine your thought process, and I would like to ask you the same of your...
No, the compiler bit, I was just playing around with the notion of, see, this is the whole idea of, so there is this whole theological argument about the existence of God. It says that if there is a creation, there has to be a creator. Okay? But within modern science perspectives, this is not necessary, because creation is self-sustaining. It creates and sustains itself on its own. And this has existed also in old theories, in philosophical systems like Sankhya. This is again true. There is no notion of God in Sankhya. Sankhya says it's explicitly atheistic because the universe is created and sustained completely on its own, by its own principles. So it doesn't require anything from outside. So this idea that a creation necessarily implies a creator, this was what I was playing around. So to say that there is a crossword, then someone must have compiled the crossword is not necessary.
You were positing in the beginning of the lecture the sort of rationality and the empiricism of science against the imagination and the desire to connect it somewhere mystically to something. But my understanding is that today it is physics and science itself which has now undermined this whole business of empiricism and absolute, because now you have this concept that you can't do an experiment without the observer influencing the, when you are talking of quantum physics, or that whole Schrodinger cat thing, or that light part, whether light is particles or waves, and sometimes like Monday, Wednesday, Friday they are particles, and Tuesday, Thursday, Saturday they are waves. You know, all this.
And Sunday they go for Parsi Bono.
Yeah. It's weird. So,
Cutting out.
that's from this aspect. That now, or is this again one of these counter projection things?
Yeah.
That
So,
now we
okay, let me say this. So, what happens is, someone mentioned Niels Bohr. So, Niels Bohr was one of the high priests of quantum mechanics, and he gave this idea of Copenhagen interpretation was essentially powered by him. So, a lot of the foundational understanding of quantum mechanics came from that period, from the 30s, when people really try to grapple with how does it make sense, this world that we don't see, which is a very, very subtle world, and how do we understand the dynamics of the subtle world in terms of our everyday quotidian existence. This was the big question. So the Schrodinger cat paradox is exactly an example of something like that. Unfortunately or fortunately, there's a strand coming from this other person, Dirac, okay, who basically said, let's completely cut out all this philosophical jargon. We can formulate quantum mechanics completely and consistently in a purely mathematical way. Okay. So let's do that and not get into this kind of philosophical interpretation of quantum mechanics. So most physicists today, would actually go along with the Dirac view, because all of us have grown up actually studying quantum mechanics from his book. So it would be, okay, we don't care whether we, in terms of our everyday existence, all we care is whether we can do a certain calculation and measure something in experiment and compare with this. So at that level, quantum mechanics is completely empirical and also deterministic. Also mechanistic. So that's why it's in fact called quantum mechanics. A lot of people like Capra and others make all sorts of statements saying quantum mechanics is not mechanical and so on. This is completely false, because it's a mechanical system, it's not a deterministic system. And by mechanical I mean the evolution of the system is governed by certain mechanical principles. By determinism I mean the state of a system cannot be determined completely. So that is the issue in quantum mechanics. But people would actually prefer to interpret it in a way which does not necessarily keep bringing these back. Having said that, of course, there are always blur areas where you are pushed at some point to confront the more foundational question. Okay, but I think that some of these questions have actually been answered over a period of time. I mean, this, for example, wave-particle duality, which was such a big thing in the 30s, our understanding of it has now changed quite dramatically. So much so that that old paradox of is it a wave or is it a particle doesn't really exist anymore.
And string theory accounts for the quantum mechanics part.
Yeah, so string theory is, so from quantum mechanics, you go one step towards building up something called quantum field theory. Okay, in fact, many of these paradoxes get resolved in quantum field theory. In quantum field theory, what you do is to unify quantum mechanics with Einstein's relativity. And you have a completely different picture of the world, and that quantum field theory is what is relevant for the world of particle physics, the experiments that are being done in Geneva and so on. String theory is another level of unification where you are trying to make quantum mechanics consistent with Einstein's general theory of relativity, not his special theory of relativity. So you're trying to address the issue of gravitation. So you can do this consistently within the string theory framework, and string theory is not the only way to do it. There are other ways to do it. The problem is to know whether this can be tested in experiments and see whether. So there is no known way to test string theory experiment or any theory of any theory which unifies quantum mechanics and gravity. We don't know whether there is any way to do experiments and figure out whether they are true or false. So does that mean we have to give up empiricism? I think that is probably stretching it a bit too far. What we have to do is figure out more ingenious ways of doing experiments rather than say that we have reached the end of the road for empiricism as we reached. But I feel that stems from arrogance really.
Can I ask you? It's coming from the background of what I find a lot of these physicists coming from, the quantum physicists. A lot of them seem to come from very conservative backgrounds like Jewish, which are inherently religious.
Tambra.
Or Tambram, There is if you go to these places, you find, I don't know Tambram, but I find a Brahm.
I'm getting rotten tomatoes thrown at me.
But
They're not conservative.
No, these are not there.
no, because there is an inherent disconnect between the families in which you inhabit, which have a very strong living culture, right? Or a set of norms by which they try to live with, and you, or the Jewish also. Jewish have a very.
But
How do
this is
you?
part of the myth building. In
Yeah?
fact, I know enough examples of people who are not all this.
Okay.
It's that these communities are very self-conscious, and self-consciousness at times allows them to keep thinking that they are great
Special.
mathematicians or great, they are specially ordained to do all this.
But there are also communities that celebrate loudly scholarship. I mean, they have a history of learning and scholarship that they uphold as a great value, right? I'm not saying it's good or bad. I'm just saying that if you come from a background where you throw that up as a big
Take a
thing,
mic.
you hear it more.
Yeah, no,
Yeah.
yes, but that's absolutely true. But I don't think it's in any way special to this community.
Exactly. I'm just saying
It's just.
yeah.
But even there, I mean, if I may, I feel that it's post globalization and what happened with the IT industry. You don't have any one coming from the south now, either whether it's Madras or Bangalore, to do PhD in any of these fundamental areas. So in fact, to some extent, that has also been clearly exposed in a way, because the intention was always. See, there is also this thing about this kind of job is somehow safer. So you become a scientist. If you're not good enough to be a scientist, then you be an accountant. If you're not good enough to be an accountant, join the railways. So that kind of hierarchies were established. The community never really pushed itself to take a risk. But then now they're finding that it's possible to do it within some other thesis. So I don't think it's anything special about these communities at all.
Because you write the characters in the book are real and not. Rather in all the serials we find all the characters are fictitious and all and bear no resemblance to living.
Yes.
So then this book will be figured in the list of non-fiction or fiction bestseller according to you. Because all these characters are, to my mind, they are.
No, you didn't read the full sentence.
No, I mean, I just.
I said the characters are real, but have no resemblance to any person living out there, and therefore bear no resemblance to any person living out there.
So they are actual characters from your observation. The names you may are getting different, but real in flesh and blood.
Yeah. Okay. I mean, basically, yes.
Can I just sort of try and understand this whole historiography that you presented of the conceptual separation between science and non-science, whether it's alchemy or literature or art or religion, and then your efforts to make these linkages with these over the separation. the way you presented the story, I felt that was it a heuristic device to leave out the social, cultural, political context, the historical context in which this all played out, which is the context of modernity, and with the heuristic device you were using for today?
No, I just took a short, smaller frame. Of course, this frame is much, much bigger.
Yeah, because
And,
it's all played out
yeah, yeah.
within a larger historical cultural
Absolutely,
context, right?
absolutely.
So it's not just a philosophical,
No.
conceptual.
No, I was just taking one link in that and trying to look at that. This is a much, much more tangled question. And of course, it is very much a product of the culture that we live in. So it's, implicated in all the historical and cultural.
Could you then speak a little bit more about how, for example, the scientific community, say where you are located, maybe in India, or, how the scientific community also plays into this divide constantly, and one doesn't see as many efforts to bring about the linkages in a more complex manner?
Yeah, so I did say this, at least, for example, at the philosophical level, foundational questions are ignored. So also, I was trying to say that, where you can look at the history of science itself, trace it back to some origin which is not necessarily considered scientific, then those linkages are also broken. So I took up these two kinds of ideas. Yeah, but one can sit and do this on a much bigger scale. And yes, it is. So this thing of selecting it out and pushing it as a privileged and special form of knowledge in the development of modernism is something very, it's a manufactured knowledge system in that sense. And in that, like von Weizsäcker says, science is not wrong in what it deals with, it is wrong in what it leaves out. So basically, it's in trying to make generalizations, you leave out details. And leaving out details and leaving out specificities, you are quote unquote wrong in that.
Or you're doing what you call epistemicide,
Yeah.
which is not suicide but erasing of
Erasures.
other ways of knowing.
So von Weizsäcker talks about a crystal that he has on his table. And he says that if you ask me to describe this crystal, I'll define it in terms of its optical properties, I talk about its thermal properties and so on. But he said, if you then ask me, why is this piece of crystal on your table? Because this crystal is like every other bit of crystal of this kind in the world. So why this particular crystal on your table? Then I will say, but when I graduated from Göttingen, my professor actually gave this to me as a memento, and it's in his memory that I keep it on my table. He says that is actually written into the crystal. It's part of the history of that crystal. But that never comes into a scientific understanding of the crystal. Because you'll say that's a very, very subjective thing, and the scientific account is an objective account. But then, like he said, quantum mechanics then forces you to come to terms with how these objective and subjective descriptions start colliding. That doesn't mean everything goes or anything goes, but at least it means that one has to start looking at some of these things more critically.
Would you be able to say that you're feeling for I'm getting stuck in words because I don't like to call it both sides, if I don't see them as separate necessarily. But would you, in your own experience, do you think that your appreciation and fondness for the arts has helped you in the work that you do with science? And how? I mean, like, how would you describe that?
I don't see that, very explicitly, because I don't see it as both sides, frankly, myself. For me, it's somewhere connected inside me, and I've never felt the need to ignore one or the other. Whether this helps that or that helps this is not completely clear to me. But I think I keep churning it, and it sometimes appears in this way, and sometimes appears in that way. And yeah, I feel enriched. Whether that's a measure of any success or anything, I don't know. But I certainly feel enriched by this conversation that is going on between the two.
So the follow-up question I have to that is that it's very unusual for me to meet somebody who feels, who doesn't get stuck in that divide that is offered to you pretty early on in school. So I would be interested in knowing how come you escape that divide.
If you do terribly on both sides of the divide, then
Is that the true answer?
yeah, actually probably I didn't see it as a divide. And also
Because you get stuck, it's like you also get pushed socially, not to...
but also I feel that I've felt for a long time that I kind of worked my way into the world of science. It didn't come, I had never could take it for granted. It was not a linear progression that I finished my 12th standard, went for IIT, went abroad, did my GRE, went abroad, did a PhD, came back. It was not that at all. So that struggle to enter the world of science has always given me this feeling that I'm not necessarily a part of that world. That I could equally have not been a part of that world. And that probably has helped me keep both identities alive.
I happened to read your this being a TIFR and this is the first book
Yes.
delving in this, or there are other books or the papers written by you.
No, I am writing a second book, but
So this is the
first book, yes.
and seeing your rather CV, it is fantastic.
Thank you.
You mentioned about science fiction early on in your talk, that you are not as much interested or dwelled into science fiction. So, considering the historical analogies you gave to ideas of modern science being rooted into other kinds of literature or something like that, I was just wondering if there are any such ideas which have analogical roots in science fiction and then being brought up into science. So, what is your take on science fiction in general, and like, do you like it, or what are some of your favorites, or what ideas do you
Yeah,
get
so
from it?
that's what, I think I never really got into reading science fiction so it's not something that I have felt very directly excited by. Because I find it a little, obvious sometimes. Because ultimately what is science fiction about? I mean, it's like saying you have an elephant, you have a peacock. Now you take the feathers of the peacock and stick it on an elephant. That is what science fiction is. Most badly written science fiction. The kind of interesting science fiction that and that eventually becomes a different form altogether because it's so good that you can't call it science fiction, and that is the stuff, for example, Borges writes about. Or our own Indian writer Amitabh Ghosh does in a couple of his books, particularly in a book like Calcutta Chromosome. That becomes so good as literature, then you stop seeing it as science fiction. Though Amitabh Ghosh did get a huge science fiction award from France. But what I'm saying is that all literature is about imagination. And science fiction is one part where you use science to then imagine things. I find that most science fiction, the imagination is rather limited. And when I said that my own work is a form of science fiction, I meant it half seriously, because ultimately we are doing that. We are just imagining things and working out the consequences. And we never know whether these will ever be verified in experiments. So it's a game we are playing already of that kind.
You are imagining possible scenarios too.
Yeah, exactly.
So are you driving science as such or the experimental? You're ahead of the curve in terms of experimental.
Yeah.
So
Too ahead. That's the problem. In our subject, and not being facetious about this, but for example, the Higgs boson, which was just discovered, which we kind of felt would be the last bit, is called the standard model of particle physics. Certain model of particle physics is a kind of audacious theory which explains all the interactions in all the known material world in terms of just 12 particles. 12 particles and 4 what are called gauge particles. That explains the entire structure of matter in this universe. And there was this last missing bit which is called the Higgs boson, which we knew had to exist. But it was hypothesized, or it was theoretically worked out in 1964. And it was discovered in 2014. So that was the kind of gap. And between the kind of theories that are being done by theoretical physicists today and the experiments, I think there will be a much bigger gap. If some of our theories survive, it will probably take another 200 years to even test them. So in fact, actually we are now bending ourselves backwards to say, let's try to somehow see within existing experiments, can we contort our theories, look at some corners of this theoretical parameter space and try to, see whether we can bring it within the, measurable domain of experiments. But it's some of these. So, for example, the idea of a quantum came up in 1900 with Planck's work. So Planck looked at what is called electromagnetic radiation and said this radiation, which was originally understood in terms of waves, he said these are quanta or packets of energy. Then he said, okay, for electromagnetism we have now found that there are these quanta of energy, and that explains something very nicely, which is black body radiation. So he said, when are quanta applicable for gravitation? He asked this question in 1910. So this idea of reconciling gravity with quantum mechanics, which is talked about now, goes back all the way to 1910. And Planck wrote a paper in 1910 on this. And he figured out that in order to have quantum effects of gravity, you need to go to very, very, very high energies. So the present energies are, the highest energy collider that we have now is measured in electron volt energy, so it is 14 tera electron volts. So, but the energies required to test quantum gravity are a factor of 10 raised to 15 higher than this. 10 raised to 15 is, as you know, 1 followed by 15 zeros. So that is the kind of. So if you are to build a collider like the CERN collider to test, if you just take this technology, scale it up, and say what kind of scale you need in order to test quantum gravity, then the collider would have to be as big as the solar system. Hopefully that will not happen. Hopefully there will be technological advances, and maybe you will be able to do quantum gravity experiments on a tabletop 1,000 years from now. But those are kind of time scales we are talking about.
Talking about.
Can I take some other questions? A lot of people.
I just wanted to ask how having a passion for literature influences or how does it influence your approach? How does it
To physics?
yeah, the physics or
But that's
science?
the question she was asking. So I don't know. I mean, I just feel probably at the everyday level, it doesn't show up. I don't think I do it any differently or any more creatively or any less successfully than anyone else. But that is part of the fact that after all, we say physicists, but physicists like a chartered accountant or, airline ticketing clerk. It's a job. So you go to the job and you do your things. It's only when you look back at it, then some of these connections help. I don't think in the everyday doing it shows up so dramatically. It's only when you collect all the things and look back at it. I think it showed for me, but personally I felt it showed much more in my book that I wrote than does in my papers. In my papers it's all about producing something instantly, completing it before someone else does, and so on and so forth. But in the book you have time to like not do a South Indian Carnatic version which you want to just finish the raga so fast and get to the vada sambar that's being served in the cafeteria. So it's a real fair version. You can see these connections.
So, how was the experience of
You have
writing
time?
a book? I mean,
Madam, you have time, one or two questions.
She's still asking a question.
Okay,
Yeah.
you are,
And I think two other people are asking after that. After that.
we can ask.
Excuse me. Yeah. Excuse me. One second. Let me show her hand this.
Yeah.
She's still asking, then he wants to ask,
Ajay,
then
okay,
he wants to ask.
that's why I asked you, no, because
so I just wanted
you are
to
calling
know
to shops.
different methods for you to write a theory or thesis and writing a novel, like a book, written.
The thesis was very badly written. No, the book, yeah, there are differences because, but actually let's stress on the similarities. And I think when I was talking to Tanvi, this got articulated a little better. Because I think in both the process, there is some similarity. Because you start from something which is when you're doing research, you start from something you really don't know. Because if you knew, then there would be no research. So, and it's actually very frightening when you start, because what will you research on? How will this problem pan out? You don't know that at all. And you think you're going to give up. You think about it for a while, you feel you're going to give up. But then, eventually just staying with it, just being there, allows you to see some light at the end of the tunnel. You pursue that, and then you start seeing the connection, and then it forms, and it becomes a tangible paper. And here again it's very similar, because if I had to write about Prahlad, how do I know? I don't know this guy at all. So how do I know what he's going to experience now? Who's going to say what to him? And those kind of things. So in that sense it's very similar. But like I also said to her, the reason I would write a novel when also I'm doing physics, is because the novel allows me to address issues which my 100 papers in physics didn't allow me to. Okay. For example, if I have to talk about a feeling of hurt I felt when someone said something to me, or if I have to talk about someone's death, or if I have to talk about the joy I felt in seeing some happiness in someone's eyes, all this has no place in physics. So where do I take all that? I need to express all that. So that's.
So you were saying that people, there is this linkage between the skeptical part of the science that is happening on the cutting edge, right? And people can kind of try to make some relation with those about extra dimensions and consciousness and all that stuff. But when you come to core science and you're talking about people, there's no connection over there. Now, is that because people from the science background are not being able to communicate the ideas very well, or is it that the people are not ready to accept the ideas that the science is producing? Or they're like, well accepted. Apple falls to the ground, that's gravity, and there could be implications of those stuff. So during a normal conversation that you might have with someone who's not from a
science. See, the thing is, the way it works is like this. Science is a huge thing.
Yeah.
In that you'll take some subdomain like physics, and then you take something more specialized like particle physics. In that you'll take some, and you're working on it. So your work is basically in some very, very, very tiny corner of a huge system. The thing is, when scientists come and sit in a public forum and try to talk, then they don't want to just talk about this very small bit of work that they did, right? They want to talk about a much bigger picture. In that, they will always, there I was trying to say that you always tend to talk about, whether your work connects with it or not, you tend to talk about ideas which challenge your conceptual schemes. And I was also saying that people, the way they receive it is interesting. It's because when something challenges their conceptual scheme, people somehow make funny equations saying that this is equal to philosophy, and then philosophy is equal to religion, and some kind of equation of that kind they make, and they then try to interpret it in their own ways. Let me share this if I can for a moment. I was doing a set of lectures for Moile Parekh Center. And so there was marathon lectures. I spoke for 3 days at a stretch for 8 hours a day. So 25 hours a day. For 25 hours I just kept speaking about science. And I thought that people are going to get completely saturated with this. And this was a completely mixed audience. There were people from all fields in that. They were not scientists at all. They were not even science students. They were just people from different professions. So I would say n number of things which I thought were equally interesting. And suddenly, few of those will go past. And then suddenly I'll see someone in the audience who reacts to something I say. And then you see like a bulb lighting up. You see that person has suddenly thought or understood what you have said. Understood maybe in her own way or in his own way, but understood it. I found interesting connection. I found that whenever this happened, whenever I saw someone light up, they would catch me outside at lunch or tea and come to talk to me and share something very intimate about themselves with me. Like tell me something about their child or about their wife or some intimate detail about themselves. It always happened, invariably. So I don't know what, I think it points to something interesting if you think about it.
Yeah, if I may, in physics, how do you define time as such? To consider it as a dimension? Because for me, I think of time as nothing but a human creation which is used to give a numerical assignment to our existence over here.
So the first part, if I terminated your question at how do you define time, that's a very, very big thing and it's a very messy thing. Can we understand time as a part of a space-time continuum? That is more your question, and that is somewhat easier to answer. That is a kind of, let's say, a mathematical trick. So basically, it's just the way our mathematical equations emerge. So it's normally we treat space separately and time separately, but when Einstein came with his special theory of relativity, one of his professors who had taught Einstein earlier and who had more mathematical facility than Einstein did, he realized that this whole thing that Einstein is saying in terms of Einstein's way of talking about it was very linguistic. He was talking about thought experiments and he was talking about a tram moving at the speed of light and those kind of things. What Minkowski did was to say that this is all very easily cast in a mathematical form, and you can simply think about all this purely in terms of so to put it very simply, if you think of time, if you just I don't know so basically time can be thought of as an imaginary space dimension. Imaginary, using the word imaginary in a mathematical sense. Okay, so in mathematics you have numbers which are called real numbers, and then you have imaginary numbers which come because you have objects like square root of -1. Do you know the person who first came up with the idea of an imaginary number?
No.
We are never told that. This guy, the same crazy guy, Gada.
Okay.
Jaime Gada. So in fact, when he was solving these cubic and quartic equations, he encountered these square root of -1, and he kept them in the equation and solved it. Whereas earlier mathematicians had got frightened when they saw square root of -1 because they said you can't have a square root of a negative number. So he kept it. He was the first person to do that. So anyway, so you have to multiply the time coordinate by the square root of -1, and then it becomes equivalent to a space coordinate. So it's a game that you play, but that game is very effective in understanding.
Just one or two.
Just one second. Let him ask. Just let him. He's been asking anyway.
Thank you. First thing, science literature, Stephen Hawkins, Jules Verne, if I'm not mistaken, who wrote 20,000 Leagues Under the Sea. Very difficult to fathom the depth of sea. So a lot of science fiction and imagination was affected. Second point is, in the right, you have said the book figures the period of early 80s. And on the page 38, I find 1942, very beautiful written. Mahatma Gandhi's vision of freedom, and that August Kranti Maidan was in the state of mess now and on. So how does everything map in? I mean, what is the time frame of these characters, these three persons? Big period of time are you trying to?
So it's just all set in the 1980s, more or less around this area, but it keeps going back and forth in time and in space. So it goes up to the early part of the 20th century, even the late 19th century to some extent, and it also goes to other places other than Bombay. So it moves to Lahore for a bit, to Calcutta for a bit, and so on.
No, what I was trying to make of these three friends are there.
They are in Bombay.
Such a long area you map it. So what is the lifespan of these three?
No, those friends are in the 80s. I take a very short span of their lives in the 80s. But using these characters, I go here and there.
Do you think there is some underlying design of why we are sitting here, apart from a superficial interest? Any underlying design in any other dimension that might be present, maybe imagined by you or by some of us? Yeah, like some underlying design. Do you think that is there, apart from, of course, our interests? Or
it's a very, very difficult question to answer. So how? No, so in fact, that's what you would call very naively coincidence. What I'm saying is, mathematically, if you start with something very random and try to ask, there's so many people in this city, why did this set up? Bring you something more than just pure random analysis. You have to bring in something which is about impulse. What is the impulse? What is the motivation? So in fact, impulse, instinct, motivation, these are the stumbling blocks for much of physical sciences right now. And forget answering such a big question as yours. If we try to use our very simple-minded, I will call them simple-minded physics ideas and try to apply them to biological systems, we already falter, because biological systems are governed by exactly this impulse and so why does a branch grow in the direction of sunlight? So that is something that okay, let me put it this way. Newton's laws allows you to completely predict the motion of a ball. So if a bowler bowls a ball, if you know the force of gravitation, you know at what point he released the ball. Okay? You know what spin or swing he imparted to the ball. You can, if no one does this, but if you were to sit and be crazy enough to do this, you can actually specify the orbit of the ball completely. Okay, that's what Newton's laws allows you to do. And you can say that the ball is going to pitch exactly here. So the point is, what was I? Sorry, I think I lost the thread here.
Design.
underlying design.
No, so the point is, this entire Newton's laws can be reformulated in another way. It's cast by some very, very clever French mathematicians, who said that actually all you need to do is attribute some mathematical quantity to it, and that mathematical quantity is called action. And the way this ball travels, the trajectory that this ball chooses, so this ball can choose this trajectory or this trajectory or this trajectory, but the ball actually chooses a trajectory where this action, this quantity action is minimum. Okay. So mathematically you can prove that Newton's laws correspond to the trajectory which minimizes the action. Action being a mathematical concept. Don't think of it as just action. Okay. So the then you can turn the question around and ask, but how did the ball know that it has to minimize the action? It has just come out of Kumble's hand. It can't be so clever that it calculates the action and minimizes it. Okay? It takes a physics student a lot of effort to minimize an action. Okay? The point is the ball doesn't know that minimized action. And this was an understanding that came from Descartes. That is why it's called mechanics. Descartes said that all that the ball does is to sample the forces instantaneously. At this point in space, what are the forces acting on the ball? And then it gets displaced to a point very close to it, and then samples it again and so on. So the orbit of the ball, or the trajectory of the ball, is a construction, a posteriori. What exists is only these different points of space and the sampling, infinitesimal sampling of this through the thing. So you get around the question of design in physical systems by this argument. But you cannot do that with life systems because there is obviously a design. There is obviously something going on there which you can't use this simple-minded. So there are